Okay, it's recording. I'm gonna write through my iPad. So my equation, I got 4.5 grams of HCI are reacted with 15 grams of CaCO3. And so first and foremost, we have to write out the equation. So it's HCl plus CaCO3. Products are CaCl2 plus H2O plus CO2. That's going to be hard to balance because it's quite messy. Anyways, so first we gotta balance the equation. There's 2 hydrogens in the product side. Let's try this. That seems about right. So we can, by check, we can do, you can see there are 2 hydrogens on the reactant side, 2 chlorine on the reactant side, 1 Ca, whatever that is, and 3 oxygen on the reactant side. Let's look at the product side. How many Cas are there, or how many H's are there? There's 2 H's. How many chlorines are there? There are 2 chlorines. How many Cas are there? There's 1 Ca. How many oxygens are there? There are 3 oxygens. So, oh, and I forgot carbon. There's 1 carbon per both sides. Yep, let me just double check that. Yep, and so now we can use the rice or ice box method. So we first create a box like this, and then create a grid of straight lines. This time we're gonna need 5 columns or rows, or whichever. 1, 2, 3, 4, 5. Wow, they're kind of uneven, but no, it'll do. And so we get 4.5 grams of HCI and 15 grams of CaCO3. First, we gotta convert them to moles. How do we do that? Easy. We find the molar mass of HCl, which I have it somewhere written on my computer. Oh yeah, 36.46. So essentially, we do the grams divided by 36.46. That equals, calculator right here, 4.5 divided by 36.46. That equals about 1.123 molars. So we can go ahead and write that right here for the I section. 1.23. This is for the HCl. This category is HCl. And now for the CaCO3, 15 divided by the molar mass, which I also have written somewhere here, kind of messy out. .0869. 100.0869. That's going to equal to 0.15 rounded. 0.15 molars. Okay, so for the reactant side, we can just put dashes here. Now for the ratio, since there's a coefficient of 2 in front of the HCl, it becomes minus 2x. This becomes x because there's no coefficient. The product side, all are x's only because there are no coefficients in front of it. So now we find the expected. We can do 0.123 minus 2x equals 0. So that's going to equal 0.123 over 2 equals 2x over 2. Cross out the 2, x equals 2.123 divided by 2, 0.0615. So that's how much, that's for HCl, CaCO3 now. That's gonna be just 0.15 since there's no coefficient in front. So 0.15. This is our limiting reactant, which is our HCl. So we can just this is also our X value. We don't need this anymore. So we can just do 0.15 minus 0.15 minus 0.615 equals 0.0885. This is not really important, but we do it anyways. So now we just plug it in, plug the X values in. So just plug this in. But since they're all they have no coefficients, there's no ratio, they're all going to be 0.0615. But we only need to find, based on the problem, the yield of carbon dioxide. So essentially only carbon dioxide, which I put as a last column. I'll just write it in anyways. I'll write all of them in anyways. So there's going to be 0.0615 molars of carbon dioxide. Now we translate this into grams. Carbon dioxide molar mass is 44.01. So we do 0.0615 times 44.01, and that equals 2. A little sloppy here, but it will do 0.0615. 2.7066. 2.707. So this is how many yield there is. So in the end, we can just write the question as theoretical yield. Oh, I spelled that wrong. Of CO2 is 2.707 grams of CO2. That's it. Thank you.